You already said a bit about it when you introduced yourself, but maybe when you have something interesting to add, how you started with Go, that would be nice to hear.
I have a whole story that includes people trying to burn me down for building stuff in Python. Uh, Basically, we have a bunch of automation tools I've written that include automating installation and testing of different software, different failure scenarios for customers. So I've written those initially in Python and done the whole cloud thing. I say whole cloud thing. I absolutely hate when people call it cloud. It's just somebody else's computer. It's not cloud, but in AWS essentially. So you'd go into this web interface, type in a customer's ticket number, hit a start button, and it would download everything, install everything, and test everything and let you know what's wrong. Automating my job basically. So I've written that in Python, and the number of issues I had, first of all, people complained that the client application I've written for it would not work on some machines, would work on others, which is the portability thing. OpenSSL being the major issue, the exact version of OpenSSL that you use if you're trying to package your Python application and so forth. So then we also had quite a few issues with the speed of running in AWS. Not AWS's fault per se. I built everything serverless. Again, it's not serverless, it's just somebody else's server. But we've built serverless, which means we didn't have to take care of those servers. It's Amazon's Lambda code. But unfortunately, when you're doing stuff with Python, it becomes real slow with Amazon libraries. So eventually, when people wanted to burn me alive, I've spent time and rebuilt everything in Go. That was my first serious project. So about 30,000 lines of code later with full automation. Lines of code isn't that much different if you're thinking about speed of development, comparing how much I've written, fairly big project for one person to write. It was about 22,000 lines of code in Python, 30,000 lines of code in Go. Most of the difference is because you tend to write a lot more error checking in Go, as opposed to doing a capture this whole block in a single exception handling in Python. So it's worked ever since, and I was meaning to code refactor it because it's proof of concept still, but it's worked ever since. So nobody complained. I haven't touched it, and that was my first journey to Go. It's like, this language is really weird. That was my first experience. Really weird. I'm used to exception handling now, and there was all this if error, and then there's a few minor weirdnesses like returning more than one variable from a function at a time. That really caught me off guard. But then once I stopped thinking in my Python ways and reverted to thinking from my old C and assembly days, everything made a lot more sense. It's like, okay, it's just variables, error checks, variable types, move on. And haven't looked back. We got loads of things that I've written over the years in Python, small scripts to help with automation here and there. And I've written them in Go since, and we've had so many less issues. I'd like to say it's language's fault, partially probably my fault, because now it's language's fault. Handling errors by capturing huge amounts of code in a single try except or try catch, if you're confirmed for Java, is just weird. Error handling per function is so much more natural and so much more fine-grained. It's absolutely brilliant. So that was my journey, going from hell of going through other languages and maintenance of those being a major pain, and going to a single piece of binary that just works. One of the tools is allowing people to easily start small lab containers on Docker on their Macs to quickly test things out with the main application Aerospike sells. Called it Aerolab because Aerospike, and it's a lab software. So I'm not very inventive on naming. So written it that actually went through being a bash script, which wasn't great, into Python that people really hated, and into Golang that it is still. And it's just brilliant. Every time I release a new version, I tell people just download this binary. You're done, replaced. There's nothing else you have to do, and it's really fast. So yeah, that's pretty much what I experienced.
Yeah, for me, yeah, as I said, a colleague showed me because we were gonna start to write an orchestrator, and they were looking like he had did some trying jobs like the code looks too ugly, it doesn't look nice, not performatic. And then he showed me Go, and then I fell in love and said like, oh yeah, you have a HTTP server production ready on the standard library. Your whole container is like 20 megabytes. It's just one binary. You compile, it runs, it's super fast. At that time, I was coding Java, right? So you can imagine the brutal difference. As Robert said, at the beginning, it's very weird, the error handling. We just use it to have these try catch exceptions or even not handle exception, let them bubble up until your Spring from Spring Boot something catches it. But once you start writing and then you really understand that, okay, every single place that can break, I know it's written on the code. You can read the code, said, okay, this can break, and that's being handled like that. So that gives so much like correctness to the code. Like it's safe because you know you're handling the errors. I remember at that time, then I was helping a friend with Python on a Django application. He had this super small function, like 4 or 5 lines. And I was looking that thing in Python, no try catch, no try except, Python try except. And there's like every single line of your function can explode at least in 1 or 2 different ways. And you have no idea that they can even do that, right? Because sometimes just trying out a new library or something that you're still learning, then you don't know that that magic or ORM can break in a few different ways, right? In Go, no, you have to handle the errors, and it becomes very elegant, I would say. Once you pass the first weirdness, like oh, this if error, everything, but it becomes elegant, becomes safe, and the performance is just amazing. So, and then yeah, after that, fell in love with Go. I've been doing just Go, and the language is simple and small enough that really very fast to get very productive and to a level that's like, okay, now everything new, I know how to find my way around it. Every new challenge, like I know how to dig the documentation of the standard library. I know how to look up how to do stuff in Go. There are many packages around there to help stuff. So another thing that
Documentation is amazing, isn't it?
yeah, Go's documentation is amazing. Like on my career, I started with Python and Django that has a very good documentation and tutorial for beginners to learning Django. So that was very good. And then I went to Java Spring Boot. That's like the documentation is okay, the tutorials are terrible. So like, okay, how you do that? But what am I doing? You just dumped me an example. If you go Django, the chapters that go step by step with you. And then go with Go, then have like the tour of Go that goes into the language. And then you don't really need to learn big frameworks because the standard library has got so many things. And maybe you just need a HTTP router here, a login library there, and most of the logging libraries they support like structured logging. That's something that like also blow my mind, like this thing is so good, you know. And then you try to do in Java, it's not that easy. You try to have a context to carry your logger with your tracking ID for your request, and the things are not that simple. And Go gives you everything for free. And yeah, and the context to cancel stuff and notify functions and things about cancellation. It's another thing that's like super good for me. It's like one of the strengths of Go. I can cancel stuff and I know that I cannot fire everybody. Hey, whoever made the request gave up. You know, I have actually a fun story about it. We had this Java application, we had one request. And then we had an error. We were looking the logs and then trying to find out. And there was this like the time that the request was running. I don't remember from where we got it. And then the number in microsecond was gigantic. And I was joking with my friends like someone like this request was processing for like a day. And I converted the thing, it was actually processing for a day. But nobody was listening on the other side, right? Whoever made the request, whoever client made the request, gave up after a few seconds. And then we just like wasting computing power, processing something super heavy for nothing. With Go, you have the context. Usually, like most database calls get canceled automatically if you're doing external network calls and your context has a timeout. The standard library can cancel that. So like, yeah, you get like, oh yeah, context deadline cancellation, or yeah, something like that. I don't exactly remember the text, but if your client cancels your request, your context gets canceled, and then everything can stop, and that's just amazing.
Yeah, absolutely. Have you found? I mean, I found that the error handling itself makes me put things in functions properly. Because if you do a piece of logic where you can error a number of times, and every time you error, you just want to exit the function, put in a separate function, it starts becoming very automatic. You start coding, it's like, no, I have to just copy this piece of code straight to a new function, because that's how it should be. It makes you factor your code as you're programming. Speaking of which, I'm not sure if Java has it, but Python does not have the defer function. And the defer function in Go absolutely rocks. Basically, if you need to close a handle, you defer its closure, which means it will actually close at the end of the function. So I can open a file, check if it opened by checking the error. And if it opened, I can do defer handle.close. And that means when my function finishes, it will run that close and can defer any number of function calls like that. It's absolutely amazing. Never forget to close a handle again.
Yeah, that's true. Yeah, that's the fair for closing. Like the first thing comes to my mind is closing the response body of the request you have just made.
Oh yes.
You know, like
rest.body.close.
Yeah, if error is different than nil, defer response.body.close, and that's it. It just works. It's really amazing. It goes back to the safety. Like it's very easy to write safe code in Go because it gives all the primitives. Like it forces you to handle all the errors or explicitly ignore them. So like you know what you're doing. We have zero values, so most of the stuff gets zero values. So it's something that should be useful. And then you have the defer for like those conditions, like closing file handles, closing connections, or anything, or even anything needs to run at the end. And then you can even, on the defer, you can even modify the response of the function. If you name your responses, like if you really need some super generic handling at some point, or just, okay, if anything goes wrong, just do something, you can do that.
Yeah, I usually defer logging line that says done with some extra things, and then I modify it if I need to. So that I don't forget, it's my done logging is going to happen, whatever happens. But yeah, the defer works great. For example, if you're trying to do mutexes, so let's say you're doing actual proper multi-threading, and you need mutexes to handle that. Anything that requires me to lock a mutex and then unlock it at the end of the task, that task is going to be in a separate function. Beginning of the function logs the mutex, and then the next line that I code is defer unlock, and then I do my stuff. That way I'll never ever forget to unlock a mutex. Kind of going into a deadlock is almost impossible unless you're doing something with multiple mutexes at the same time.
Yeah, that's true. Yeah, this mutex is just love it. It's basically the pattern: lock, defer, unlock.
Yeah, exactly.
It's just beautiful. If you need mutexes, I mean, lots of stuff you can get around with channels and waiting groups. But if you need to use, yeah, I think I've never seen a language that gives you so much, like the guarantee. Yeah, I'm gonna close them. I'm gonna like unlock my mutexes, no deadlocks, and the whole deadlock detection of the runtime and the Go thing. You can run --race detect also race conditions, and the deadlock also works so good. Usually you get like a say, hey, you have a deadlock, instead of get your program hanging for like, what's going on?
Yeah, and the next thing you discover as soon as you go through this, or at least I did, the next thing I discovered is its benchmarking features, where you can do CPU profiling. Something's taking loads of time. You do a CPU profile, and then because I hate reading profiles in text mode, I generate an SVG with a single command. And you're looking at an image in your browser that's basically got these blocks that mention how long each step took in a block. And the way they're drawn is the bigger the block, the longer it took. Basically, you open it and you know, right, this function is taking the longest amount of time. It becomes so easy to figure out where you need to optimize your application. For me, it was fmt.sprint. Turns out it's really heavy. But yeah, it's brilliant. And going on to that, you then learn how Go threading works, or should I say Go routines. Go routines are like, they're not lightweight threads. I don't even know how to describe them. They are like thread. Go starts a number of threads. Yeah, they're Go routines. Go will start threads, as many threads as you have cores. And then when you start Go routines, it's like a layer above it. It's tiny routines that you can start and stop. and Go handles the actual timing of when each routine runs. It may seem counterintuitive for speed, but it's actually a lot faster because Go knows exactly when code should wake up and when code should sleep, as opposed to the kernel, which would basically gives you equal opportunities to every single thread. Go knows that something's about to sleep for 10 seconds, just not gonna wake that Go routine up for 10 seconds if your time.sleep, because why would it? So with that, you can end up running hundreds of thousands of Go routines on 2-core machine, and it's more than happy to do that without any major issues. Go routines are absolutely amazing, and the communication that you learn between Go routines, like you mentioned, the channels are great. Channel is essentially a thread safe variable, and then you can create buffer channels. Like I'm trying to translate it to no Go language here, right?
I'd say a thread safe queue, a synchronized queue.
Yes, basically.
It's more like a queue than a variable.
Yeah, it's a thread safe queue, but it can be buffered as well. So you can create a buffer so it can hold. By default, if you try to push something to the queue and something else tries to read from it, and something else isn't reading from it, you're gonna be blocked. But you can create a buffered one so you can store up to whatever amount you want. And that queue can store anything. So you define your type for the queue, but you can store whole structures, integers, strings, whatever. Absolutely brilliant.
It is, I think these Go routines are not a big thing. Go like just like in the end, just a few kilobytes. That's what a Go routine is, a data struct, and the runtime does everything, and just schedules, and it works. You just need to be a bit careful because there's some stuff like it's still Go routines. They work on a oh my god, forgot the word now. It's a cooperative scheduler. So the Go routine needs to yield execution at some point that the compiler inserts. So like you can do a for loop that just does like add stuff without calling function thing, and then your Go routine is going to run forever. So there's like 1 or 2 gotchas there that it's very rare to stumble on them. Most of the time you don't need to worry about them. But if you do profile on something, you can see what's getting stuck there. And and most of the time it just works and super lightweight. And it's what's powered the whole HTTP stack that makes Go so great for microservices, because in lots of applications, like most of I've worked with, like a microservice that reading from a database or communicating with other microservice. So like 95% of the time, my Go routines are just waiting for like a database call to return, for a network call to return. And then the Go routine gets blocked, Go runtime puts another Go routine to be executed. And you get this crazily amazing performance because you don't block a whole thread or a whole OS process, because just waiting now, we can have like 10,000 Go routines waiting for 10,000 different database calls. And that just works.
Yeah, which is absolutely fine. The only thing that sometimes catches me with short-lived applications is I tend to forget for some reason, because most of my applications are long-lived. So I tend to forget that when your main finishes, all your Go routines die immediately. So yeah, why didn't this log? Oh, it's in a Go routine. But yeah, other than that, it's great. So imagine you have a piece of application code that does some things, and then halfway through it needs to send a message to Slack channel. So we'll call it message to Slack as a function, and then it does some other things. So you got your code, and then the message to Slack takes some time. You don't want it to, so you want to put it as a background job, right? So in Go, it's as simple as typing Go space in front of your function name, Go space message to Slack. That's it. It's going to run in a separate Go routine in the background. It can't get any easier. So those are the little things you learn through the experience of that really steep learning curve. But once you go through that steep learning curve, it's like, wow, this is so easy.
Yeah, exactly. And like most of the stuff you can find in the official Go website and Go blog. You'll have like concurrency patterns in Go. I think they have like 2 or 3 very good blog posts that go through different ones. So like even like how to use those primitives are given to you by the writers of the language. Not like you need a different framework or anything. Just use that, and then you learn how to use waiting groups to make sure your Go routines are finishing before you finish your main function and things like that. If you're writing short-lived process, if you're more in the HTTP world, sometimes you don't even need to worry about the existence of Go routines. It's just handled under the hood, but every new request is a Go routine somewhere, and everything.
Wait groups rock. Every time if you have a bunch of Go routines that are your background jobs, you just create a wait group, add the jobs, and inside your Go routines, you do done.
Yeah.
A function called done on that job, and on your main function you do .wait. You're done. It's just gonna work.
Yeah, I think the whole concurrence model patterns in Go makes so easy to work with threads. Like I've tried to work, I've worked with threads in Java, C, and Python, and none of them get as easy as with Go. Because yeah, we
C
have the
was
channels.
difficult, but not as difficult as Python. I found working multi-threading with Python to be hilariously difficult. Whole tracking of your threads and maintaining them and making sure that they do what they're supposed to and that your thread's safe in some libraries and not in others was just horrendous.
Yeah, I did a bit, not much, so I don't have that much experience, but all of them were very cumbersome. And Go, like, yeah, you go, you have your wait group, and it just works, you don't need to worry about what's happening when it's running. No, the scheduler does everything. You just need to know your primitives, like your channel, it's gonna block for you or things like that. And you have your wait group. Sometimes you need multexes. Depends what you're doing. You really don't need multexes. Usually with Go routines, the channels and wait groups are gonna be more than enough. And they're high level enough that they're very easy to use, to learn, to understand, and even to reason about when you have a mistake. Or something is hanging you, like, oh, you have a deadlock. You just think, read your code, or are the channels like closed, haven't I forgot to close a channel and then I still have a Go routine reading from it? Or did I actually do my wait on the wait groups in the right place? And yeah, just the code gets very easy to read even with concurrence. And it, yeah.
Great, thanks. Yeah. So I try to see if we have another question. I think most things have been answered by now. Yeah, that was one question. You were talking how you were getting into Go, and now the question would be, how do you use it for DevOps? Of course, you said already a bit about it during your introduction, but maybe you want to add something here.
I'm thinking what to add here. Considering, like I said, DevOps is quite a loaded word. Depends what you mean by that exactly. But let's say we're talking about a DevOps pipeline. So we have of applications written in Go. It's really easy to do a DevOps pipeline. I don't have dependencies, right? As long as my code compiles somewhere early in my pipeline, so that will have dependencies to compile. Obviously, but once it compiles, there is no dependency anywhere. It's a single binary. My DevOps pipeline becomes extremely simple. So I'm a fan of GitLab. I'm also a fan of AWS pipelines. I'm a fan of anything that is in Jenkins because I had really bad experiences in the past. So with any pipeline like that, it's fairly simple. As long as your code compiles, I normally have it deployed in a test system and then piece of automation to run to do every single possible thing to break it. Call it functional testing. And then we typically deploy it step by step, percentage-wise. So we tend to start with 5% deployment and then move on and speed up as we go along, deploying more and more to the new binary. But like I said, with Go, it's simple. You're replacing a single binary. You're not updating libraries on the actual servers that are going to be running your DevOps, which is, I think, the biggest thing. When you think DevOps pipeline, you're thinking, right, I need to incorporate operating system updates to libraries that my code uses. So for example, Python libraries that need to be there, Python executable, etc. When I think of DevOps pipeline in Go, I'm thinking the OS needs to be updated naturally, and I need to replace my binary. That's it. And then if you're using Docker, then you don't even think of the OS that needs to be updated inside your containers or Kubernetes. It's like, I need to replace the binary. And I just replace it slowly. If nobody complains, I continue until I've rolled out fully into production. So that's my favorite part of the DevOps pipeline with Golang. It's the fact that it's so easy to do without wondering about, will this break something that I haven't thought of because there's some library somewhere I didn't consider.
Yeah, so the way like I'm using it now is actually with Jenkins. So like we have this whole pipeline set up on Jenkins. And at OneFootball we run everything on Kubernetes, and we use Helm to deploy the applications. So basically we need a Helm chart that in the end of the day is just a collection of the Kubernetes manifest files, like the service, the HPA deployment, they get bundled together, right? On what Helm calls a chart. And it gives you some templating features. So Helm is also written in Go, and basically you can write Go templates on your Kubernetes YAMLs. And you have a few more facilities to get values from different places, aggregate them and everything. And one thing with Helm is every time you deploy a new shard, you need to bump the version, right? And then you have this process that we developers are manually editing your Helm chart, like to change your configuration, add environment variable, and then it goes to GitHub and needs to go to a pull request approval. And then the most common thing is like you forgot to bump the version of the chart. So one guy had this idea, yeah, if we, instead of actually writing Helm charts, we write a small manifest of the application on a small file, like we use in Tom, so like app.tom, that says, okay, that's the name of my application. I'm saying that's HTTP service. It needs to run on this URL, has this path, has these environment variables for configuration, and of course can have different environment variables for different services. And then we get that, we compile in a Helm chart, and then you get it in deploy. So that's the automation we have with Go. So it can read this app Tom, generate the Helm charts, and then it writes the Helm charts, it calls Helm, renders the charts, then goes to GitHub, creates the pull request, then goes to GitHub again, approves the pull request, because we have this GitHub interface with a repo with all your charts. That's the interface we have, and it's like, okay, let's build automation that one day might replace it, but for now, as a small experiment, we keep the interfaces, we just automate the manual work. And then it does everything, it updates the chart version and everything. And then make sure that everything is ready there. And then the pipeline of actually deploying goes, and everything runs on Jenkins. So what we did is, of course, it's a Go application. We Dockerized it, so you don't even need to worry about installing it or maintaining the right version on Jenkins. So, and also because it's Go, it's a very small container, it's very easy to say, hey, just change those, like you mount the volume of the Docker container, change the values. Every time we release a new version of this automation that we call Helm charts generator, we also generate new Docker versions with the new application, and it gets very easy to update the pipeline, very streamlined. And you have all the nice features with Go, like nice logging, all the error handling, the type safeness, everything. So it actually has really improving our speeding up and the whole pipeline of changing an application and deploying and reducing the time we take to actually make a change, especially in configuration, because things like, oh, we forgot to update the chart version, that means that Helm is not going to deploy a thing. Doesn't happen anymore. That's automated.
Yeah, great, thanks. I think the next one, what you see as benefits of Go and for Ops SRE. This is, I think, something we talked about at length already all the time, kind of. So would be interesting if you see any cons too, any downsides or so. Something that you might be missing from Python or shell scripts or whatever else.
Definitely Go is in its early days compared to, don't get me wrong, it's stable as hell. There's no stability issues, but it is in its early days compared to, for example, languages like Python or Java. So while you can do most of your things from get-go in Go, if you're looking for some advanced libraries that would be replacing a load of the work that you're trying to do, trying to think of a good example, but Django that Tiago mentioned, it provides you a huge amount of external extra libraries, some of which are already available in Go, similar functionality, but a lot of it that Django can do, Golang just can't do yet, so you have to code your own. Because it is in its infancy days compared to languages that's been around for 15, 20 years. Those languages have a huge mature amount of libraries that are just not present in Go yet. You can do most of the things in Go, almost everything. Okay, you can do everything in Go, but some of the stuff you'll need to code yourself, as opposed to picking an off-the-shelf library because somebody has made it. So that's a difference compared to other languages. That's the stuff I'm missing. If I'm not comparing to other languages and just thinking of the cons in Go, with the learning curve, there are a few captchas, a few things where you can kind of hiccup and go, why on earth would it work like that? Most of the examples escape my mind right now, but I had quite a few moments of what the hell's going on here. So that's those kind of things will catch you out very early on. Once you go through the learning curve, it all becomes normal. But interfaces was definitely one of those. I had a serious issue wrapping my head around interfaces. An interface is a kind of thing where, just to give you a bit of a view on that, with an interface, you can accept a variable which of any type, and then reflect upon it to find out what type it is. When I said reflect, I literally meant the reflect function library. And then an interface can be defining what kind of functions your structure needs to have to basically implement a particular, I don't even know if there's any other word than interface. I'm trying not to repeat myself here, but it can be it can be defining a bunch of functions. It can be defining a variable of any type. It's there's some things that take some time to get used to, and that's probably an afterthought that was bolted onto Go and then became normal. But other than that, I can't think of anything. It's just a steep learning curve, really.
Yeah, I think on the cons, I'd say like the thing, like especially talking about automating stuff, shell script just common, right? So everybody sees a shell script and said, okay, it's a shell script. Maybe I don't understand it, then I Google it, and then that's it. And then with Go, you're gonna have a binary somewhere. So I think it's more about culture than actually a downside of the language, because it gives you all the benefits, but you just need to get used to like learn a bit Go in the same way you need to learn shell script, right? Because if you're just doing a sequence of commands in shell script, that's very basic. So even in Go, it's going to be very easy. But when you start writing complex shell scripts, then you need to learn a lot of shell scripts. Also, gonna have to learn. So, but it's not like you can Google that tiny bit of that shell script that you don't understand what's happening. No, you need to learn the whole language, the whole thing. And it goes more to the programming side that just hacking something together with a bunch of commands, shell commands. But yeah, that's the learning. But yeah, aside that, I don't really see any cons. I think it brings you a lot of advantages if the whole team is willing to learn and to just like, okay, now you need to ship a binary instead of a text file and things like that. And just to comment on the whole interface thing you're talking about, Robert, I think the interface for me in Go, that was very easy to understand because it's coming from Java and Python. So Python have duck typing. So things you could just say, I expect you to have this method. They're just gonna call the method, right? And in Java, you need to say, hey, this class implements that interface at compile time. So it's very rigid. So you cannot have dynamic things like we have in Python. Then you kind of mix those two concepts and you have interfaces in Go. You know, when you say, okay, I accepted this interface, so I'm going to use this interface, any type that has got those methods is going to fit, is going to be used. Most of the time, you don't need to know what's under the hood, which type you're getting. You just know, okay, implements the interface, it has the methods I need, I can use it. And I can still reflect and find out, okay, what's actually the struct that's implemented. And then you have the empty interface. That's okay, that's whatever. That's like object in Java. Or I think also object in Python, something that's like the basic class for everything. And that's when things get tricky. And then I think it's in the Go proverbs, like emptying the Rob Pike says, empty interface means nothing. Like it doesn't tell
Yeah,
you anything.
It's not difficult once you get your head around it. Once you get your head around it, it's like, oh yeah, it makes absolute sense. It just took me some time to figure out how that ties in, because I was trying to constantly compare it to C, and that that kind of threw me off.
Yeah.
But on that, the thing is, you mentioned the binary, and that reminds me, depending on the culture of your business, that might be considered a con. I consider it a pro, but you can't just log into a server and change a line of the code because it is a binary, right? You need to recompile it. You need to copy it over. You can just fix stuff in Python. It's like, oh yeah, just change that. It will make everything work. You can't do that in Go. You have to ship the binary. I consider a pro. Some people will consider it a massive con, depending on how your pipeline's configured and what you're doing. And on that very front, the strictness of the language is a massive pro, but it can be annoying, right? I'm coding and I'm halfway through code. I defined variables I know I am going to use very soon, but no, I can't just run and test it because Go is going to refuse it because I defined variables that I haven't used. So when we say strict, it's really strict. You can't define a variable and then not use it because that's a waste. I'm sure there's a Go run switch that might allow me to override it, but I haven't even looked.
I don't think there is.
No, in that case,
honest, I don't think it should be implemented.
No, it shouldn't. But at the same time, yes. So it's a massive pro, but it's also extremely annoying. So you can put it in the pro and con column. It's when you're just midway through coding and you want to quickly unit test something part of your code. Yeah, you can't. You really need to finish your function and use your actual variables, or comment them out, because otherwise it's just going to complain.
You can help with that with a little trick. You can assign this variable to underscore, like underscore equals the variable that you don't use yet, like behind the code that you have written already. And when you have multiple variables, you can have commas and them all listed, and then you need the equal amount of commas and underscores before the equal. It's not beautiful, of course, but it's clean.
And for testing, it's temporary, right?
Yeah, and it's obvious that this is a temporary hack. I think everybody sees that line and says, well, this can't be something that goes through a review or anything, right?
Yeah, my trick for that's a different one. I just print everything. Like I start coding, then I put a print statement at the end of my function, print, and then I go put in my variables that are not being used there, and then you end up with this print for like 5 variables there.
Yeah, I do that quite often. I have a print at the end of my function which just prints all the variables I'm not using, just so it will run.
Compile my code. I can just save my code and get it correct. So Go can format my code, because I think
that's usually where I put my breakpoint. It's on that print function. It's like print all these functions, and I'm gonna put my breakpoint there just to see what's happening.
No, this so rarely I use a debug. I just printf statements usually. Most of the time to me it's enough for logging. And but yeah.
Cool, thanks. I can see if I have a last question maybe, but not really.
Somebody asked in the chat 10 years ago they were written in Ruby. Any idea why it changed? Yeah. I think I'm too young to remember Ruby.
Yeah, I never used Ruby as well. Never actually, I don't think I ever seen Ruby on automation or anything. Just Python shell script.
Yeah, when I joined the serious IT industry site, Perl was just slowly dying with people moving to Python and PHP.
Yeah, and I think Ruby is in many ways comparable to Python. They are often like twins that are fighting each other a little bit or mocking each other or whatever, right? Python tries to be a bit faster, and both aren't good with multithreading, and yeah, I think Python is a bit stricter syntax-wise. Ruby is for a bit more on the lenient side, where you have multiple ways to do the same thing. But otherwise, I think it should be for this topic. Hope I'm right. Quite comparable. I didn't use Ruby a lot. I did 2 months of real professional Ruby usage, and before that I tried to learn the language like 2 times or 3 even, but I always ended up with a Python book in the end. I don't know why, but yeah.
That was my experience with Java. Every time I started with Java, I somehow ended with Python code.
I had that once too.
I mean, Python is great if you really want to hack something really quick and make it work. Like I needed to parse a massive log file and split it into a bunch of log files using tabs. So I quickly tried to hack it in Bash, but because you end up with a loop, it takes absolute ages. So it managed to process about 100 kilobytes in a minute out of a couple of terabytes. So I hacked it in Python, about similar amount of code, and it was good enough and it was fast. It was not worth building it in Go if I could hack it in 4 lines of code in Python. So it's got its uses, and that's probably one of them that it makes absolute sense.
Good, yeah. Thanks. Do you have many or any more war stories you would like to share? Something nice, inspiring, maybe for somebody who is trying to get his hands dirty with this. And
for Go, definitely pick a web-based small project. That's, for me, that was the best way to learn. I tried starting with other things and quickly got lost. Took me a few attempts to actually get started with it. But starting with a web-based, small web-based project is the best way to go. Pun unintended there again. Documentation is great on that. Loads of examples. Standard library handles your HTTP server, and you can extremely quickly get started and just create your first website. That also uses multi-threading under the hood, although you're not exposed to it. Well, Go routines under the hood, but you're not exposed to them per se. But you quickly learn that you want to carry variables between your functions. So you start using methods instead of just functions, and that quickly makes you implement slightly more, and you learn huge amounts while implementing just another slight small feature. Like you start adding a config file that allows people to configure, or allows you to quickly configure what is going to be the port you listen on, and you implement a few command line switches, and then before you know it, starting with that, you quickly have learned methods, structures, functions, huge amounts from start to about you're halfway there. The next project you want to pick will be something that implements Go routines after that, probably, because that's quite a big subject. But starting from HTTP server is probably the best way, because it defines a clear path of what you're going to be building, and you learn how to achieve it pretty quickly.
Yeah, I think that's a great advice. I'll just add to that, try to stick to the standard library as much as possible, especially on the learning curve, so you can actually understand how Go works and see what the standard library provides you. Because like it has the flag package. Of course, I think there's the Cobra and Viper that also lots of people use for configuration, that allows you to do command line argument like the same way, in a similar way, but it adds, you have to learn this framework and everything. So stick to the standard library one to understand, because let's say 95% of the time it's more than enough, and then you don't need to pull up a gigantic library for that, and then you're really learning the language. You understand it, that how Go works, reading the documentation, because the more you use the standard library, more you force yourself to read the documentation, then you get used to read the documentation, and then you learn the details of the language, and then just get used to this like cycle, like, oh, I need something, oh, I've seen this package, go there, you read. And yeah, I think for Go routines, to have a small application, maybe a small web crawler that needs to fetch like multiple things in parallel, and then you don't have to wait for all of them to finish. I think that's a classical example.
Yeah, I've actually built
coroutines.
my first Go routine was actually a copy application, like CP, copying files, but multi-threaded because NVMe's can handle it. So I would have two threads and two buffers, and while one thread was reading into a buffer, another thread would be writing. And that quickly teaches you how to use channels, waiting on your Go routines to finish. Channels, or you could get away with mutexes if you wanted to, but you can do it both ways and think about which one works best for you, or even benchmark them. But yeah, that teaches you pretty much everything you need to know about Go routines. But other than that, web crawler is also great because there's just massive parallel execution with waiting and launching more routines. So you can launch huge amounts of them instead. But pretty much once you're done with a web crawler, a copy application, and a web server, you pretty much know Go. And the last thing to cover then is unit testing, which well, you either love it or hate it, right?
I'd say love it. I like the testing package. I think it provides everything you need, and it's simple. It's built in the language, so again, you don't need to learn another framework. Just the language. It's simple enough. Of course, you don't have like assert dot something. You write an if statement, but in the end of the day, it's pretty much the same thing. And I've seen a few already of those testing frameworks that come and go, or even the writers are like, oh, these things got too bloated. There are too many functions.
They're way too complicated.
And then
they're
they
way
go
too complicated.
Something simple, just testing package like the t.fatal fail error. It works, and then there's a thing. It's the standard Go, so any Go developer have gone through it, have seen it somehow, and then you can get any project that is mostly based on the standard library with the standard testing framework. You just read the code, you understand, and it has lots of functions you need, like subtests, things like that. You can also skip tests, like, hey, this test is not going to run for this reason, so you can skip.
Benchmarks, it's part of the actual test library.
Yeah.
And code coverage.
Yes, and code coverage, and you can even generate HTMLs that shows you, like, if not a flame graph, but like with colors like green and red parts that are covered and not, and that's very easy. You can even put that on your like CI/CD pipeline. Every time you create a pull request, it generates the HTML files and lets you see them, or something like that. I actually use a tool that lets me to see that on the browser directly. I just run the test every time I save a file. But yeah, just read everything, and then I say every time I save a file, run a test. I know if things pass, so they can check easily what's covered, what's not.
Yeah, I even got I found that VS Code will actually, if you run a test package and tick the box that you want to do coverage with your test on the package, it will actually highlight all the code in red that hasn't been tested. So you can, and the files on the left side where you have a file list, it will highlight those in red. So you can easily go there and just scroll down and see which parts are missing. Absolutely brilliant.
Yeah, that's very nice. And as we're talking about testing, the HTTP test package is also something that everybody should check out. So Go provides you literally a package that can start a whole web server on a real port, that it just gives you, just say like server.start. You just write a small HTTP handler to run on that web server, and then start. Of course, you need to do the fair server close, but it's testing code. If you don't really do that, usually it's not too bad, but you should do. And then you can literally test your code. Like, you just mock the response, but you have the whole HTTP stack running. Literally, your test code connecting to your same binary, same test binary that has another server in another port. And even the actual port is transparent because you do, I think, server.url and you get the full URL with the port. So if your code is configurable enough, you just use this stat package. Like, I use it all the time. As I said, I write lots of applications that calls other applications, and then just put your small JSON there for the real response. You can do your HTTP status codes handling, because you define also a function to be like the other side, the HTTP server you're mocking, that could be all within your testing function. So it knows it has the whole scope, so it has access to the testing, the T for the testing framework, so it can actually do assertions, HTTP server, like, have my application built the URL correctly, have it made the request of the right method, right parameters, right headers. And you can literally look at that from the side of the receiver who's receiving the HTTP request. So that's also very powerful.
I just sort of two catches for people. Mention some cons or some weirdnesses. So one thing that caught me out quite recently actually is I ran out of file descriptors. I had to run a long-running Go application that would be poking HTTP ports of a few hundred test servers at random times with some stuff. Not going into detail, it just needed to do a lot of HTTP calls over a long period of time. And about 24 hours later, it died, ran out of file descriptors. Turns out that Go will never close a file descriptor for a successful HTTP connection, unless you specifically tell it to. So your standard http.get, that's not going to close. You actually need to specify that you want to close idle connections after a certain amount of seconds. I mean, it's great in one respect because it means it reuses the same connection if it can keep it open, and it becomes really fast if you need to keep communicating with the same server from your Go client. But if you need to do some stuff in a random fashion, you're going to run out of file descriptors, and that was something I've learned pretty fast on the HTTP package. So it's one of those things. I have another, but that would probably require a code sample. So I'm not going to go that much into it. I might publish it later for people to look at and scratch their heads at it. I might actually have published it on Play Golang. I'll hand this over for a second and I'll see if I can find it.
Okay, I would have, here is one last question from the chat. So that would be based on your opinion. What now isn't Go, but you think it should not? So if there's anything inside that you find shouldn't have become part of Go or is annoying or something like that.
Well, I think it might be very unpopular, but I think generics. I'm not sure Go really need generics. I think it depends on the code you're writing. Up to today, I never really needed generics or anything like that. So, and that's one of the things I like Go, because I think if you start introducing generics, you can really start writing some ugly code and things can get messy. So I think Go could stay without generics, at least for all the use cases I needed. And yeah, but aside that, I don't think there's anything else that comes to my mind.
I lost the Zoom window there for a second. No, I can't think of anything. I agree on the generics, definitely. But other than that, I can't think of anything that made it there that shouldn't be there. It is a pretty bare bones, strict system with a bunch of libraries that give you the basic stuff. It was obviously built initially to handle HTTP things because HTTP made it like really early on into Golang. But again, you import what you need. It's strict in everything, including its own design, in that it doesn't tend to pack things that it shouldn't be there.
Yeah, and it's simple. I think when someone asks me why do you like Go, I said because it's simple, it's small, and I think generics is a feature that I don't think that every programming language needs to have all the features. I think that's the point, right? And Go, you have so many things that allows you to somehow write generic code. So, and if not, you can just quickly write what you want. Like the first example to generics that comes to my mind to handle data structure, like, oh, I need a list of type X and this list of type Y that you can add, remove, pop, and things like that. And okay, that gets annoying Go because you cannot really write that without generics. But I think it's a very specific use case. And a lot of times you don't really need that, depending on the application, of course. So I rather keep the language simple. And I think it was Robert Pike who said that Go solves 100% of your problems 8% of the time. or something like that. So like there are a few applications that Go is not really meant for that. So maybe go for Python or something else. And for the other ones that Go is meant for, it's just amazing. And keep things simple. Like I'm a huge fan of simplicity code that's easy to read.
Yeah, I found my code that doesn't work. So for whoever's interested in finding out a weirdness in Go, I shared a link on the chat here. It's in play.golang.org. It had me scratching my head for a while. This is a simple example of what didn't work. I was actually trying to do some machine learning and plotting of numbers. So it was slightly more advanced than that. But this is a simple example of something that's really strange. So for those who don't know, if you do colon equals, that means you're normally colon equals means you're defining a new variable. So Robert colon equals 5 means I'm defining a new variable and at the same time assigning a value of 5. Robert equals 5 means I'm reusing a variable called Robert and reassigning a different number to it. But that's not always the case. I'm gonna leave it at that. I've a bit of homework for whoever's interested.
Yeah, I'm looking at your code like, okay, what's going on here?
Fun, right? It can really catch you out, this one. But for whoever wants to know the answer, they can. Oh, object-oriented pattern in Go. So the only thing in Go, I'm gonna leave this example for whoever wants to scratch their head. You can somehow ping us through after this call if you want an answer, if you found it. It's just a fun exercise. For the question that just popped up in the chat, object-oriented pattern in Go, I'm guessing you mean using methods, which is assigning, it's a function attached to a struct essentially. Which is, I think, the closest thing I can think of with object-oriented programming in Go. You kind of need objects to handle things. And because of the simplicity in Go, you can, for example, start a web server and tell it which functions will handle which paths, for example, / index of HTML / something else / admin will be handled by different functions. So by default, when somebody lands that path, for example, that function will be called that you defined in your router. The problem is that function on its own, it's not going to do anything interesting, right? It's got no configuration variables unless you're defining globals, which is a bet. Globals have their place, but that's a very tiny place that you should really avoid. So unless you want to do globals, which is a really bad idea, especially for your router applications for HTTP, you need some way of passing variables to functions that will otherwise get called by another library. And the only way to do that is to basically create something similar to an object, which is, you define your object from the struct, and then you have functions on that object. And you can pass that object function into there so that it can carry some variables like your configuration. It's something you can't avoid. Like I said, if you want to be able to pass functions to other libraries for them to call your functions, and at the same time have some kind of configuration passed to that function at the same time, it's a global or it's an object. There is no other way to do this. And globals are really bad. So in that respect, I think the Golang has just the right amount of objects or object handling and object design with the structures and the functions, not to make it object-oriented like Java, where your main is a class, but at the same time it doesn't become really obscure and weird to use either, because it feels quite natural to use them when you need to.
Yeah, I think when I read that, my mind goes to a different direction. Think like about those OO patterns, like those like from the Gang of Four, those famous book, like oh my god, it's not programming patterns, but like those patterns to solve problems, like observer, factory, and things like that. So I think like lots of the time with the features that Go provides you nowadays, you don't need some of those patterns. I wouldn't say all of them. Some of them are very useful. But I think what's important to understand about those patterns is like they are meant to solve a very specific problem. And lots of the time you have a variation of the problem that's not that specific. And maybe that pattern is not exactly you need. And Go provides you other tools to solve it. So to be honest, most of the time I don't really find myself thinking about like those patterns, even though I studied them at university, use them a lot. But there are many ways that you could solve the problems using those features from Go without like being like, let's say, super strict of like, oh, I'm going to implement my part on X with like all those details, you know. You can, for example, you can just pass functions around as values, and you can do closures to capture values and things like that. Like for example, in HTTP middlewares, sometimes I have a function that returns a function that the returns actually a HTTP middleware. The first one receives some parameters and passes it around, and then you get it on a closure, and then it's just there. So you don't need to actually implement a struct to receive the value. So that like you can already deconstruct some patterns on that. I just thought about an example that's like running away from my head. That was something related like that. But yeah, there are many, like, let's say, simpler ways to solve small problems that's not building the whole design patterns. Yeah, design patterns. That was the word, design pattern thing. I had another one in mind, but yeah, I forgot.
I think mainly this whole inheritance thing is not so strong in Go, right? You can do something like that, but it's less strict inheritance like in Java or C++. It's more a kind of combination of multiple things into something new. And yeah, this is a little bit different, and that takes out a lot of pain. I personally think, and yeah, even though it's not a full object-oriented language, I think it's a much more pragmatic one, and you can solve all the same problems just in a simpler way. But that's my personal view on it.
Yeah, I think it's got just the right mixture of objects and no objects to do what you need to do in the way you need to do it in the right places. You're not constrained to using just one or the other. You got just the right mix. Inheritance is great. You can now inherit bugs. You don't need to code your own, right? But on that respect, doing something simple. For example, I tried to copy data from one file descriptor to another, which was a lot of data. So I tried to implement a progress bar. Now, there's a number of ways you can do that, including writing your own buffer and copy a little bit at a time. But my favorite approach was to just create a pass-through object that implements essentially what you call a reader or io.reader interface. And I loop around to the original reader interface when I get called. And that's it. In my function that does the read, I read from the original one, and I do the pass-through. And I inherit the whole io.reader inside my object, because that was just one line plus one to keep track of how much was copied. So I got 2 lines in my struct design. One of them is an integer to keep how many bytes I copied over. So it allows you to do what you want to do in any number of ways. If you really want to avoid objects, absolutely fine. You can do it with a for loop and doing a small copy with a buffer each time. And that works as well. So it gives you just the right mix to do things the way you want to do it, whatever works for your scenario.
Great, thanks very much. I have one last question that's a bit my personal one. I haven't done so much Go for DevOps, and I would be missing all these little shell commands like copy. I know you can copy stuff with the standard library too, but this always needs a bit more ceremony around it. Is there some library that gives you like most of the Unix shell commands in a nice to use way, especially for people who know those quite a lot already?
Most, yes. There's a OS library, and that's got functions that are really easy to find. os.rename, os.remove, os.remove all if you want rm-f, rm-r. Then you have os.mkdir. So that's anything you would normally type in to create directories, remove files, move stuff around. And then if you want to read files and write files, there's io-util. It's kind of a wrapper around the actual IO library as another and does a lot of the basic stuff for you. So you can do io-util.read file and io-util.write file, for example, to just read whole file and write it back. Obviously, you don't want to do it on a 1 terabyte file that's going to end badly. For that, you'll want to do something, of your own. But unless you have 1 terabyte of RAM, in which case I take it back. But other than that, for basic use, if you're just trying to do something that you're doing in shell, io-util and OS libraries have pretty much everything you need, apart from copying files, which weirdly enough is not there. If you want to copy a file to another location, you need to create basically 3 calls with some error checking: open source file, open destination file, and then do io.copy to copy from source descriptor destination. There is no shorthand for it. It would be nice if it was in the OS library, but I guess copying isn't exactly a syscall, because at the end of the day, we're doing syscalls to Linux. Moving files is syscall, removing is a syscall, copying isn't. Copying is an option of opening source, opening destination, and reading from one, writing to another. So that doesn't exist there. Having said that, there's loads of examples on the web, and so you just have to have one function that's approximately 15 lines of code or less to do that, including error checking.
Okay, great. Thanks a lot. So just using the standard library again, if I understand correctly. And as a side note, the io-util will be kind of deprecated, I think from 1.18 on or something like that. It's of course still exists, right, for compatibility, but the functions will be moved to proper OS or to proper IO. And that's where they naturally belong stronger anyway from the thing that they are doing. So they are a bit easier to find probably for new people.
Makes absolute sense. io-util was always the weird one, where
we can't hear you.
If I didn't do any IO stuff that required me one of those libraries for a while, I'd first try to find it in IO, then OS, and then I'd go, yes, io-util is the wrapper one that wraps things around. So it makes sense that they're moved to their proper libraries.
Yeah, that's true. And actually, if you look, there's like 7 functions there, so it's not that many things as well. But yeah, temp tier and things like that. Yeah, that's actually good to know. I didn't know that was going to be deprecated. But yeah, good to know. Going to make things simpler.
It's not a huge deal, right? Your code won't be broken or something. Yeah. It's just when you write new stuff, do it, and when you touch the old stuff, it's nice when you are using the new Go version too, right? I feel that people are more and more reluctant to switch to new Go versions. Do you feel that too?
So I've switched. I was always loved cutting edge, because why keep it working if you can break it? But I switched to a new Go version, and I've learned the hard way that nothing I've put in a directory other than go/go/source compiled or worked anymore, because Go turns on something called Go modules by default now. That's a big captcha, and I think the Go module and dependency handling was and still is really weird. Going back to the cons, it's just weird. Initially, it didn't really exist. Well, initially, it didn't exist at all. Then it didn't really exist. Then it kind of existed with third-party libraries or binaries. And now we move to Go modules, where you basically define which commit pretty much, or which tag in Git you're going to use as your dependency, so that you don't have to use the latest and greatest. People release different release versions, and you can keep using that version. It's a bit weird because you had code that worked. Somebody starts screaming that some web dependency change, you need to quickly change your code because nothing works. So you quickly change it, and then you can't compile because you update your Go binary. And now you need to do modules, and you spend some time finding out how to turn them off. It's an environment variable, by the way. So Go modules is something really strange for me still. I haven't really moved on to Go modules yet.
Yeah. Sorry. Yeah, go Robert. Sorry.
Yeah, it's I still turn them off, and I manage my dependencies how I used to, which is keep them in separate directories, or in my own forks, because that's what I've been doing until Go modules went mainstream. It just, the fact that they turned it on by default at some version really caught me off guard there. But dependency handling is one of those.
Yeah, I think that's a very interesting point in Go. You have this compatibility promise that every Go 1, it's gonna, like, every program written in Go 1 still compiles as long as we're still in Go 1, and that still holds nowadays, right? So that's your program is gonna compile and run. However, this promise is not true for the tooling. So the behavior of the Go tool changes over time, and I think the Go mod is the best example that lots of people got bitten for. Even though if you configure Go modules like on, off, whatever you need correctly, your program still compiles and the program still runs correctly because you have the Go 1 promise, but you have to find that out. I also had some issues. I was using the past DApp even before Glide, and then Go modules came. It is a bit weird. I mean, they did enough releases of like as optional, but they at some point said, okay, that's the standard one, so it's on by default, and then if you want, you can switch off. But I think it's worth reading a bit and investing some time and learning. Once I learned it, it's very natural. I was using Red DApp and Glide, so I had this tool taking care of the dependencies for me. So transitioning to Go modules, it was a bit more natural, just learning the new syntax and everything. But I mean, I think dependency management, I think, is hard in any language. There are different approaches. I like Go modules. It works. It works well. You need to understand every now and then, because of this whole transition period. And I mean, there's no way to transition those kind of stuff without breaking some like tooling, like in the sense of like breaking some scripts that depend on the behavior of the Go tool. But I believe that the Go team did the best they could to give people enough time to change and update. Of course, I also got bitten. Like one day, my thing didn't work, and like I had one GitHub Actions test pipeline that just couldn't run in 2 different conversions because of this switch. And it took a long time to find the right environment variable to set. But yeah, I think once you learn it and then you start get used to that, it works pretty well. I think that's it.
You have to learn Go modules at some point. So my good example of where not doing proper modules bit me, I was using a PayPal library on one of my side projects. It was library version 1 point something, and that worked. At some point, I updated my Go code, and I did update my libraries. I did go get, tried to compile. It no longer compiled because now it pulled version 2, which was the latest in the repo. And now I'm screwed. So the only way I could do that was to find the correct commit that was still the version 1, fork into my master fork, and use that from GitHub to basically do this. If I used Go modules, I wouldn't have had this problem. At that time, forking was the quickest solution. I had to really hurry to deploy this. But yeah, that's one of the things you're looking at. It's once you learn and use modules, you will not have this dependency problem or dependency hell that you might hit. And that you reminded me with, not sure what you said, well, you reminded me, but one huge pro of Golang is cross-compiling. I code on a Mac, I compile for Linux and Windows. Right? It just compiles. 99.9% of things will work across OS. You have to be doing something really corner case that won't, in which case it will probably inform you.
It
You
just
can,
won't compile.
yeah, it won't compile, and then you can create your source code _windows.go, literally, and create 3 different versions of just one particular function for different OSs if you need to, and then the compiler will just pick them out correctly. But that's for real corner cases, like you're actually trying to do Win32 kernel calls or Linux syscalls. 99% of things will just work.
Yeah, I discovered that, like, the syscall, I think the syscall package, the package that has the signals, Linux signals, it doesn't exist on Windows. So yeah, this cross-compiling, it's amazing, because like if you try to cross-compile C, it's hell. You need to download the whole toolchain and everything. With Go, you just export the environment variable, and the Go tool in any machine is gonna compile to any other machine, any other architecture that Go supports. It just works. It's beautiful. And then I was talking about that with a friend, like, oh, I can compile that for Windows. Export the environment Windows, like, syscall doesn't exist on it. It's like, oh, interesting. But those packages, I mean, either gonna get bitten when compiling, or if you already know, just do, like you said, the underscore on the name of the file, or build tags at the beginning of the file, say build on Windows, don't build on Linux. That also, it has the same effect. And yeah, and they have your code working in multiple platforms and everything, and very well organized also, very easy to read. Even though the name of the file, it's just there, or that's the first thing in the file. So you open the file like, oh, build tags, okay, I don't know, exclamation Darwin or something, so you understand what's going on.
Yeah, so 99% of my code, for example, may be same for all the platforms, and then there's this one particular function call that I need to make differently on Windows and Linux. So it will be in its own function in a separate files, one for Windows, one for Linux. And that one particular function will make the correct call depending on the OS and return the same kind of return in a couple of lines of code, and the rest of it is shared. But that's only, like I said, if you're doing something quite corner case, really. For anything you're doing HTTP, or if you're trying to join paths, you use the path.join, the actual path library. It's part of standard Go libraries. It will join it correctly. It will use the / for Windows, / for Linux and Mac, and whatever else might be supported. So it correctly joins paths for you. So as long as you don't try to hack your own path handling by adding / something for Linux and then wonder why it doesn't work on Windows, you're fine.
Yeah, great. Thank you all so much. And I think we are already a little bit over time, kind of. But yeah, great. Thanks. It was a nice discussion.
I have to ask, somebody asked just now on a chat if we're doing lost and found hiring part. What's lost and found hiring part?
Right. That's something we want to do now. That's completely right. Yeah. Absolutely. And by the way, I found the bug on the Go playground that you gave the link to, and it's hilarious. But yeah,
absolutely
can talk
brilliant,
afterwards.
Right?
Maybe we do this as a present afterwards, right? So then let's get quickly to this lost and found H&R part. So it's what we usually do before our first break. And yeah, today we don't have many breaks, so we do it right now. And it's about if you want to hire or want to be hired, then you can get the mic for 20 seconds. Right, that's the gaming part of it. And so it won't get boring for everybody, and everybody has to speed up a little. And yeah, so if you're looking for people contributing to open source project or so, you can raise your hand too. And I would just set up a timer quickly. So let's So, this has been easier before. Okay. So, who wants to be first? I can guess. Yeah, Aman and Janos. Yeah, cool. So, and Tiago too. Okay, let's get Aman and Janos. You think you asked explicitly. You can go first, please. And yeah.
All right.
Can start now.
You hearing me, guys? Are you hearing me? Yeah?
Yep.
All right. Yeah. Thank you. Janusz and Amnon here, coming from Frogster, a risk AI company doing a lot of cool things, everything in Go. We're looking for a senior Go developer for my team. We're doing a bunch of awesome, very complex projects. If you want to chat about it, I'll be happy to. Janusz here from HR. I'm here from the team. Feel free to reach out. We'll also drop our emails in the chat if you want to chat later. If you find a friend that you want to pass it through, pass it through.
Okay, thanks. Yeah, Tiago, you want to go next?
Yes. So yeah. So I'm work at OneFootball or whole backends Go. We even start building some automation in Go. We have open positions for all levels. To as backend in Go and also Android, iOS, web. Actually, have a huge list of open positions, and a few new ones should appear soon. So yeah, if you're interested, you can go to the careers page or can reach out to me directly on Twitter. I think my Twitter handle, I think it's somewhere. Or yeah, so it's in the careers. I'll send my Twitter handle as well.
Ding. Cool. Yeah, you can use the chat to communicate how to contact you. And you are welcome if you are in the Gopher Slack. We have a Berlin channel. There you can put in a link or something to, right? Because there are most of our attendees are in this Gopher chat and Gopher Slack channel. And then, cool. Great. Anybody else? I don't see any raised hands. Sometimes you can use this raise your hand electronically too, if you like. Otherwise, we can start and talk about this funny bug on this playground and how to solve this, or what really is the bug there, right? I think I found it and corrected it, but
Yeah, it's a
yeah,
it's a fun bug. It's a very cool thing.
yeah, it looks so idiomatic and normal
Yeah.
that you glance over it and think, yeah, that's just
Yeah.
idiomatic Go code. And then you think, and then, oh,
Exactly.
damn.
I got beat in production because like it was like you always iterate of an array that 99% of the time has one element, and then there's the corner case with more than one, and then they got bitten. Like yeah, but once you learn, it's obvious and makes sense.
One of the good examples of where you would use this a lot is if you have arrays of strings and you're actually doing AWS, using AWS libraries to use to do stuff with AWS, and they normally accept a list of string pointers instead of list of strings, and they will return you a list of string pointers. And if somewhere in your code require a list of strings, you want to convert that. And you know those conversion methods will tell you if you do what I did.
Yeah. And it's fun that the correct solution is very idiomatic. Looks weird, but then it look like no, that's very cool, idiomatic. And yeah.
Shall I say what I think was the
Yeah, go
real
for it.
bug? So there is this first for loop where you range over the list of strings, which is fine. And you append to the list of string pointers, which is fine too, of course. That's exactly what you want to do. But you always append the same string variable or pointer to the same string variable. So this one variable can in the end only hold one value, and
it will hold the last value that you assign to it, right?
That's exactly.
This is basically where I said where you do colon equals means new variable and equals just means reassigning values to variable. And then I said usually in Golang, if you're defining a new variable as part of your for loop, so you do for item colon equals and then a range, it will only create that item variable once and then keep reusing it throughout the for loop. Makes sense for speed, because 99% of the time you just want to iterate. But for a case where you actually want to create pointers, you need to create a new variable inside that for loop every time, doing the colon equals into a new variable again. So you have like an extra line, my item colon equals item, and then use a pointer for that.
I mean,
that's how you did it.
Go and you could do item colors equals item.
Yeah,
I'm gonna send the playground that like I saw that like that's very dramatic because you just keep things within the scope. It looks a bit weird, but once you understand what's going on, it makes sense, and then you don't need a new name. And there are lots of places in Go actually kind of use this pattern of using the same name on testing or with subtests a lot. Just use T everywhere, and then because of the scope, you always have the right thing there. So yeah, it's a very interesting thing.
I did it the other way around, kind of. Instead of another line, I just did the for loop around the indices. So I can just get this for loop here inside, I hope. Getting dark in my background now. So I just range over the list of strings. I just get an I here for the index, and I don't get the items at all. And I append the pointer to the string that is at this index. So it's a compact, but it's of course more stuff in one place, right? So yeah, you have to see what you prefer, but I like that you actually see, okay, I get a pointer to each of the strings in this array or in this list of slice, really. And so that's the most idiomatic way I could come up with, but everybody be his own judge there, of course. And there are many ways to do it in the end, right? This item is funny,
yeah. It's great because somebody who's unfamiliar will look at the code and go item colon equals item. Yes, it does. And why does it even work?
Yeah, but
right?
Yeah, the good thing, like especially if Go and like the language server, like Go please and everything, most of editors can actually highlight the scope of the variable. Like you put the cursor there, and then you get like every place that the same scope, you get highlighted, and then you can even see those things actually working there. Because I think other languages just highlights the string everywhere, but most Go editors actually highlight you the scope of the variable, not the name, and then you can see those things. That item that one item is one thing and the other item is another thing. But yeah, just redeclare that inside the actual loop implementation. And then if your loop is very big, then you don't need to have this mental brain work. It's like, oh, I'm iterating of item there, but I convert to something. No, it's just item. And after this item columns equal item, that's weird. It's just item is the variable that's in the loop, and it's just an independent variable. You can use the pointer for it. You can do whatever you want. It's going to work.
Yeah, having said that, the for loop range thing is absolutely amazing. The amount of times I use range, colon equals range, to iterate through lists is just hilarious. When I started in Go, I started with for I colon equals 0, I smaller than length of my array, and then I plus plus, as you would do in most languages, or most C-like languages. But no, in Golang, that's kind of weird. You can do it, but it's just weird. If you don't, you can just do range, and actually you get 2 variables returned from range, which is your iteration number and the actual item. So you can do for I comma value in range, and that will give you the I will be the actual iteration number, or the number inside the list. Much more readable and clear than the standard for I colon equals 0.
Yeah, that's only one catch. If you only have one variable, so variable name colon equals range, blah, blah, then you don't get the items, you get the index. And this is sometimes people, especially from Python and so on, I think, tripping over that, and myself quite sometimes too.
Yep, is the for underscore comma item that you need to do.
Yeah.
Which takes some getting used to. Once you get used to it, every time I need to go back to Python these days, I do really weird things, and it doesn't work because I'm so used to doing the underscores where I should put underscores in Golang now.
Yeah, it's just it's like this core things that looks weird at the beginning, but then you get used it. You just learn it makes sense. If you do that on a map, you get the key. If you don't have both variables there, and yeah, I think afterward it just makes sense to me to know. Yeah, if you're just doing, then you get the index, then you can use the index, and then for example, if you just do like index columns equal range my array, then you can use, as Oli said, for the string pointer thing, and then just have the index. It's very compact. If not, you can get both if you need, or just one.
Yeah, speaking of which, a map will return, so a map will return 2 things, right? So you can iterate through a map and you get the key value, or just key. Or if you do underscore comma, then you can get value, but you can actually go for, if you do map, the actual map item, so you open your map, square bracket, input item, that also returns 2 values. The first value is the actual value, and the other one is a Boolean that says whether this actually exists. So you can actually test if your map values exist by checking the second variable that's returned.
Yeah, that's great. One last catch that I found with this for range thing, if you're using the Go template library, there it is again the other way around. There, when you have only one variable, you will get the item and not the key for maps or the index for lists. And
yeah, the templating is weird, right? It's kind of, it works, but I feel it's not powerful enough for some of my needs. I end up doing some really weird hacks with creating extra lists. But then again, how much code do you want to put in your template?
It should be enough, I think. And you can add extra functions. You can add Go functions as extra things there, and this should be really powerful enough. I do this very rarely, but done this once for internationalization purposes and so on, right?
Yeah, but because they try to keep it simple, so you don't put too much code in your template, that's you end up with your for loops actually contain the item only, which tends to be a bit weird if you're currently doing that part of your Go application where you're jumping between Go and templates. You can get pretty confused there at some point. So yeah, that's one of those. But templating is great. It's absolutely brilliant. It's something I remember writing about 15 years ago in PHP, my own library, to do templating because I had enough of PHP code inside my HTMLs, or HTML inside my PHP code. And Go just does it, just like that, which is amazing.
And you can get the exact same syntax for simple text templating and clean HTML templating, where you have all the safe things with escaping everything and so on the right way. This is really beautiful too.
Oh, yeah, absolutely. And on that front, I mean, I don't like JSON because I don't like JSON. I guess it's a kind of hate-hate relationship. But if you need to work with JSON, and you probably will, Golang's JSON handling is amazing. It's strict. So if your JSON is really bad, you will have a really hard time doing something in it with Go. You'll end up, you can actually marshal your marshal is the one, your JSON into a map. And that will create, with interfaces, and then iterate through it using a package called reflect to find out what's inside each interface. If every item in your JSON list contains very different map values or map key names, to be exact, but by design JSON, you should have the same things. If you have a list, you should have the same things in your keys. And receiving a lot of things in JSON is amazing in Go. You can create your structure, create JSON tags to say what it will map to, and only the stuff you really want from the JSON return that you get. And then you unmarshal the JSON into your structure or object from the structure, and it will just do it for you, and it will only export the stuff that you mapped it to and ignore the rest of the JSON. So yeah, absolutely great, and much stricter, and for the most part less painful than Python, unless, like I said, you're actually doing different keys in different parts of your list in JSON, in which case you're doing something wrong to begin with, right?
Folks, I need to go.
Yeah, sure.
the dog.
Family
It's
time. I
quite
see.
late.
Yeah.
Yeah.
Cool. Yeah. Thanks for joining. Really. Thanks. Was great having you. Thanks a lot.
Bye
Bye.
bye.
Bye. Yeah. Thanks to you, Robert, too, of course. And yeah, I can feel those things. Yeah. I don't know. Do you like XML and YAML a lot better? Or do you have any format that you really like, or do you think they're all painful?
They're all painful. No, so we have a format for configuration. I went through, so I like to think of formats in two different types. You have format that you use for configs and format for data. For configs, I settled on YAML. Is the least painful of them all for me, at least for me. I tried to use TOML, but with TOML you can't easily create lists. Like I want list of I don't know, instances that will allow a user to start through my automation. With TOML, it's a bit painful because you have to do the double bracket thing. With YAML, it's just minus this, minus that, minus that. It just makes it much easier. Having said that, YAML is painful because it resembles Python. I mean, have you ever seen a Python developer's keyboard? The tab key is absolutely gone. And the same thing goes with YAML, right? So that's the painful bit. Somebody's using tabs, somebody's using spaces, you're screwed.
Yeah,
so that's
one of the points. Yeah.
Yeah, that's
it's
for
context.
Yeah, that's one of the things that really annoyed me in Python. Is the fact that I have to tabulate my code exactly like the other guy. Either use tab or 4 spaces or 6 spaces or 8 spaces. But for data, JSON is probably the least painful one. I don't like XML because the amount of ways you can carry your data is just hilarious. I can carry it inside these triangle things, whatever they're called in XML, or I can carry it inside. I can carry it as part of my declaration or just as text inside those as an inner text. It's like, no, can't I just have key values? I mean, that's all I need for 99% of my time. So I absolutely hate XML. JSON is least painful. I still hate it.
Okay, thanks.
Blobs are great, right? You can always store just binary blobs on your disk with Go.
Yeah, think there's even a good package like what is it called? Glopped or
Is it actually
something?
called? Yeah, there's actually one called binary.
And there's extra something that didn't catch on much, but it would be a Go version of protobuf or something like that. I
Yeah,
think.
it
And
didn't catch on much, but it was the one where you could just marshal a struct into binary and store it on
Yeah.
disk, which was
yeah.
absolutely brilliant, I think. It didn't catch on much because it's not really portable to Python or Java, and everybody else supports JSON already.
Cool. Yeah. So thanks having you all here. Right. And I say goodbye now and stop the recording, of course. So great having you here and goodbye. Have a good night.
Yeah, that was brilliant. Thank you. Bye.
Yeah.